Now let's look at number 8. For this one, we want to start finding all the solutions between 0 and 360 and then find all the solutions. This one, it's not asking for exact solutions, it's asking for solutions rounded to the nearest tenth of a degree. So that means we're looking for answers in degrees, and we're going to use our calculator with an inverse function, and you have to make sure your calculator's in degree mode. Let's start with this one by solving for the cosecant of theta plus 30 degrees. First, we'd solve for the cosecant squared by adding 9 to each side. Now we can solve for cosecant by taking the square root of each side. That's going to give us just cosecant on this side. On this side, we're doing plus or minus the square root of 9. That's going to give us plus or minus 3. Here's where we're going to use our calculator with one of the inverse trig functions to solve this for theta plus 30 degrees. But your calculator doesn't have an inverse cosecant, so what we want to do is change this to sine instead of cosecant. Since sine and cosecant are reciprocals, if cosecant is plus or minus 3, that means that the sine of theta plus 30 degrees is going to equal plus or minus 1/3. So we're taking the reciprocal on both sides. Sine is the reciprocal of cosecant, and 1/3 is the reciprocal of 3. What we want to do is find our reference angle. We should have 4 different angles that have a sine value of either plus or minus 1/3. We can find our reference angle in the first quadrant by using the inverse sine. So we would do the inverse sine of 1/3. In this problem, it was asking us to round to the nearest tenth of a degree. So I'm going to round this to 19.5 degrees. This is our reference angle in the first quadrant. It's also going to be one of our solutions for theta plus 30. For the second quadrant angle, if I take 180 minus 19.5, that's going to give me 160.5 degrees. In the third quadrant, I'm taking 180 plus 19.5, which is going to give me 199.5. For the fourth quadrant, I'm taking 360 minus 19.5. That's going to give me 340.5 degrees. Now what I have for my theta plus 30 degrees, 19.5, 160.5, 199.5, and 340.5. In order to solve this for theta, that means that I need to subtract 30 degrees from each one of these. That gives me just theta. When I take 19.5 and subtract 30, that gives me negative 10.5 degrees. Since we want these all to be between 0 and 360, we're going to have to change this to a positive fourth quadrant angle. So we're going to have to find the coterminal angle with this one. But let's go on and do the rest of these. This would be 130.5, 169.5, and 310.5. So now we're going to change this to its coterminal angle by adding 360. That's going to give us 349.5 degrees. There are 4 solutions between 0 and 360. For part B, it asks for all solutions. So all we have to do with that is take each one of these and add 360 times n to get the coterminal angles. There are all of our solutions.